Hi, we're going to discuss text files today, and all the programs I do in this video are going to be provided as links in the description, which you can open and see for yourself. And I hope you've subscribed. We'll start by looking at files and the need for a data file, different types of files like text, binary, and CSV, opening and closing a file, relative and absolute paths, access modes for files, methods to read, write, and manipulate text files, and standard input, output, and error streams. So what is a file? It is a stream of bytes comprising data of interest which can be stored in the computer's storage devices for later use. And it can also be defined as a named location used to store related information or data permanently in a non-volatile memory. Text files have normal text and an end of line character, which indicates the line's termination. There are other special text files in Python, such as the CSV files or the delimited file. A CSV file or a comma-separated file is a special type of a text file which contains data values that are separated by commas, and it stores tabular data in plain text, in which case each line will have the same number of fields. For example, the CSV file could contain name, address, and email. In that case, the CSV file will have the same data in every row. Binary files are different from text files because they store data after converting it into binary language, that is zeros and ones, and so there's no end of line character. And this type of file returns bytes. This is the file to be used when dealing with non-text files such as images or exe files. Whenever you need to read a file or write to a file, we need to open it first. And when we are done, it needs to be closed so that the resources that are tied with the file are freed. The IO module is the default module for accessing files, and you don't really need to import. The built-in Python function open is used to open a file, and this returns a file object, also called a handle. The open function has many parameters, but the first two are the ones which we are going to use most often. That is the name of the file along with its location and the mode in which it needs to be opened. When we are done with the operations to the file, we need to properly close this file. This will free up the resources that were tied with the file and is done using the close method or function. You can open a file using either the absolute path or the relative path, and this depends on where your file is located. If your text file is in the same folder as the Python script in which you're writing, then you need a relative path, which is only the name of the file. Otherwise, you need to specify the drive, the folders, and the subfolders in which your file is located. In the absolute path, you need to either give double backslashes or use an R string modifier, in which case you don't need to give double slashes. Otherwise, any mistake in the name of the path or the name of the file will give you a file not found error. We can open a file in two ways, either by assigning it to a variable name, which stores the file object or handle. And in this case, we need to close the file specifically, or we can use the keywords with and as and write with open, name of the file, give the mode as, and give the name of the variable which will store the file object. Close the statement with a colon. After all the statements within the block are executed, the file will close on its own. We're going to open a file using the statement open and assigning it to a variable fo, which will store the file object. And we try to write a string to this file. If we do not have a close statement and we try to open again and read this file, we'll see that it does not output anything. In case we use the close statement, now we'll see that the string has been actually written to the file, and that's how we can read it. In the other example, we are going to use the statement with open as and give the name of the file object. In this case, we are not closing the file. However, when it will still be able to read the information stored. We'll now look at file access modes. Whenever we open a file, we need to specify the access mode in which we want to work with that file. The access mode R is for reading, and it opens the file to read only. It starts from the beginning of the file and it's a default mode. So if you do not specify the mode, R is the mode that's taken. File not found error is reported in case the file does not exist. R plus is similar to R. It's only that we can also use it for writing. The W mode opens a file for writing only. Again, the file pointer is placed at the beginning of the file. It overwrites the data of any existing file and creates a new file if there isn't one already. W plus is the same as W, but also allows you to read from the file. The append mode A opens a file for adding information, and the file pointer in this case is placed at the end of the file and it starts writing from there. It creates a new file in case the file specified does not exist. A plus is the same as A, but it also allows reading information from the file. We now look at read, write, and append mode. We start by writing a file, mytextfile.txt, and we write the following string in this file. We close the file and we then open it to read the file. We add some more information. Again, we're going to read the file using the method read. So when we execute this, we'll see that the first time it shows us the first string, but in the second output, it has shown us the appended string. In case we want to only output a certain number of bytes, we'll be able to do that if we write the number of bytes within the bracket after read. Once a file is open in any of the access modes, we want to perform some action on it depending on our requirements. And for this, we are going to use file methods. The read method reads at most n characters from the file, and it reads the entire file if n is negative or if read has no parameters. Read line reads and returns one line from the file, and it reads n bytes if n is specified as a parameter. Read lines will read and return a list of lines from the file, and it will read n lines if n is specified, otherwise it reads the entire file. The write method is used to write a string to a file, and it returns the number of characters written. Write lines writes a sequence of strings to the file, and the sequence could be an iterable object like a list or a tuple. We now look at the usage of write lines, in which case we need to pass an iterable object. Here we are going to pass a list. And we also use write, in which we are going to give a simple string, and we are going to append this to the file. Now, once we open the file to read, we are going to use three methods: read, read line, and read lines. And we'll see how we get three different outputs. Now, in the first case, it's going to read the entire file using the method read. For read line, it's going to read the first line, which is Java and Python, because there's a \n after Python. So that's the beginning of another line. So it reads only that first line. In read lines, it's going to store each line as an element of the list. So the entire file is stored as a list. We are going to look at three special methods: seek, flush, and tell. Seek method is used to change the file pointer position to offset bytes, and it can be referenced from start, current, or the end of the file position. It cannot be negative. That's only possible for binary files. Flush method is used to flush the write buffer of the file stream, and the tell method returns the current file pointer location. We're going to look at the usage of the flush, tell, and seek method. And we start by writing a string to this file. In this case, we're using the flush method instead of close, and that will be able to write the string to this file. We'll open the file to read it, and we'll use the method readline to read one line from the file. We'll also use the tell method, which will return the file pointer or the cursor position. We're going to use the method readlines, which is going to output all the lines of the file as elements of a list. When we execute this, we'll see that the output for readline is the first line. 23 is the output we get after using tell, that is the cursor position after reading the first line is at 23. We use read lines and it starts reading from the position 23, that is the 23rd character starts reading with read lines, and as you notice, each line has been put as an element of this list. If we change the file pointer or the cursor position to 0 using the method seek and passing the value 0, now when we execute, you'll see that it has started reading from the first character of the file. In case we pass the value 10 to seek, when we execute, we'll see that it starts reading from the 10th character of the file. We're going to look at a program to find the size of a text file. We start by writing a string to a file called demo file. We open it to read and we store the entire contents of this file in a variable called read_data, for which we're going to use the read method. We then use the len function with read_data. Now read_data actually has the entire file stored as a string in this variable. So finding the len will give us the size of this file. However, it may contain blank lines and end of line characters. So to remove those and see the size of the file, we'll be using a for loop, which is another way to look at the contents of a file. So we start by opening the file in read mode. We also use a variable file_size is equal to 0, and we use a for loop saying for line in file_handle, and we say L is equal to the length of line.strip. Now strip is the function which will remove blank lines and end of line characters, and then each line's length will be stored in L, which will be added to the variable file_size each time. And then we get the size of this file without spaces and end of line characters. When we execute this program, we'll see that the entire file size is 224. However, without spaces and end of line characters, it is 219. We're going to manipulate data in a text file. We start by writing a string to the file data file in write mode. Then we open it in the read mode, and we use the function read to store the entire data in a variable read_data. We also have another variable vowel_str, which has all the vowels in upper and lower case. We have the for loop to read each character in this file. We use the if statement to check whether that character is a member of the vowel_string variable or not. This is a great way to use the membership operator. And in case it's true, we will increment a variable counter by 1. We also declare the counter equal to 0 to begin with. Now, once we've done that, we are going to also split the data of the file using split function and store it in a list. We then use the len function to find the number of words in the list. And we're going to use the same list to check each word of the list and add this hashtag character at the end of the word. We'll then use the upper function to change the entire file to an uppercase. So when we execute this, we'll see that it gives us the number of vowels is 31, the number of words in a data file are 14, and it's also added hashtag at the end of every word in the file. It's also converted each character to uppercase. We're going to look at standard input, output, and error streams. Python's sys module provides us with file-like objects that represent stdin, stdout, and stderr. To use these objects, we need to import this module and then assign these objects to a variable which will store a handle for them. The standard input is the file handle that a user program reads to get information from the user. We give input to the standard input, for example, the keyboard. The standard output is the file handle that the user program writes the normal information to, and the output is returned via the standard output, mostly the monitor. The standard error is the file handle that the user program writes error information to, and errors are returned using this file handle. We'll start by looking at standard input, and we import the module sys, and we use sys.stdin, which we store in a variable stdin underscore file. We also have a variable to count the number of lines being input. Now we use a variable entered underscore line. So this is going to check what is the line in this for loop. So for entered line in stdin underscore file, if it is equal to quit or exit, then it will print bye bye I quit. Otherwise, it's going to print the line, and it's also going to print the number of lines that are entered by the user. So we use the stdin and we enter these 3 lines. So note that each of these lines terminates here with a full stop. And when we execute this, it will show us these 3 lines, and it will also show us the number of lines entered are 3. If I'm going to write quit here and then execute, so it's going to write bye bye I quit, and then it's going to give me the number of lines. We now look at standard output. We're going to import the module sys. We'll store sys.stdout in a variable stdout underscore file number. We have a list, which is input underscore list, and this is the list. For line in input underscore list, it's going to print this using this variable and the function write. So when we execute this, it's going to give us the output from the list. We'll now look at standard error. In this case, we are going to use the stdout as well as stderr, because stdout is to output the result of the error. So we have 2 variables, stdout underscore file, which is going to store sys.stdout. We have stderr underscore file, which is going to store sys.stderr. And we have this list sample underscore input. We also use the for loop to read each element of the list and output it like we did in standard output. But we add an exception here where we divide each string from the list by 20. So it's going to raise an error. So when we execute this, we'll see that each time the line is read and it's divided by 20, it also gives us an error, which is generated by stderr underscore file. So that was a little bit about text files and standard streams. You've also got the links which you can check out, and I hope to see you very soon.